Okay, this is a still 37. This is B. I have to keep these videos under 10 minutes, so that's why I kind of have to break this one up. Now B says, when does a particle speed up or slow down? Now remember, speed increases when the acceleration and the velocity have the same sign, and it slows down. Speed slows down when the velocity and the acceleration have different signs. All right, so it's going to speed up when those are the same. So what I did was I looked at my graph. You could graph both these. I don't think I have the graph here right now, so. But you can see that basically if you look at your acceleration or your velocity, I should say, your velocity, if you looked at the graph, your velocity would be 0. Between 0 and 1.5 it's positive. And then from 1.5 to 3 it's negative. And then after 3.18 it's positive. So you could graph that. Let's see if I got that on here. Yeah, here's your velocity, so go back and look at this. So this was the velocity function right here. So again, if you graph it, you look at the graph, you can see that over here, and this was the 1.15, here it's positive, then negative, then positive. All right, so that was the velocity. So I put that over here. So it starts at positive, negative in here, that's positive. And this is when it was moving to the left, so you can see from your graph here. So it was positive, negative, and positive. So this is the range here between the 1.5 and the 3.18 where it's negative. Now the acceleration, that's just given by this line. Now I could set that equal to 0, and I got 2.17. So it was negative to the left of 2.17 and positive to the right of 2.17. So you can see that. So this was the acceleration. That was just the derivative of the velocity. And I found out where it was equal to 0, and it's negative to the left, positive to the right. So what I did was I kind of analyzed it. So from here are the signs. Here it's positive velocity, negative acceleration, so I'm slowing down. So I'm slowing down from 0 to 1.5. And then at 1.5, they're both the same sign, so I'm speeding up from 1.5 to 2.17. And then after 2.17, the acceleration is positive, but this is still negative, so I've got opposite signs, so I'm slowing down. So I'm slowing down from 2.17 to 3.18, and then after 3.18, the acceleration is positive and the velocity is positive, so I'm speeding up. So that's kind of how you have to figure that out. Okay, so I just made a little graph here, and I looked at my graph. So velocity positive, negative, positive, acceleration negative, positive. So these are the points. And again, when velocity and acceleration have the same sign, speeding up, speeding up. When they have opposite signs, slowing down in here. Okay, all right. Okay, then the rest of it wasn't too bad. 37C, so it's not too bad. When does a particle change directions? Well, it changes directions when the velocity is 0. So you can go back and look over here. So when the velocity is 0, that's when it's changing directions. And I also had that on my graph. So I actually had that information down. So it's 0 at the 1.15 seconds and the 3.18. And I approximated these. Now letter D, when is a particle at rest? Well, it's also at rest when it's changing directions. All right, so it's changing directions. See, when the velocity is 0, all right, that's when it changes direction. That's when it stops. So it's the velocity is 0 when it changes direction, because it has to stop to change direction. So these are the same. So this is when at C, this is when it changes direction, and this is also D when the particle is at rest instantaneously. Just for a moment it stops. Like we said over here, it starts this way, stops instantaneously at 1.15 seconds, and changes direction, stops, changes direction, like that. So those are the same. And then letter E, describe the velocity and the speed of the particle. Well, we kind of did that. And that was, if I go back to B, this is the velocity. The velocity, they said describe the velocity and speed. Well, again, my velocity is positive, then negative, then positive. And my speed is, like we said, decreasing here, increasing there, decreasing there, increasing there. So those are basically the same. Sorry about that. Let me get back up here. So I'll go back over that again. So describe the velocity. The velocity is positive, then negative, then positive. And the speed, because of the acceleration, the speed is decreasing because I have opposite signs, then increasing because I got the same signs, decreasing because I've got opposite signs, increasing. So that's what's happening with the speed. So that's kind of like the same thing as B. So I don't know why they asked you all these different questions, because some of them are redundant. And then letter F, when is the particle at the point 5,2? So that means the value would be 5. So what I did was, basically I just graphed, and you can see here, this is the position function here. And then this is the line y equals 5. So when the position will be at 5 is where it intersects, and these were the three values they had. So if you want to find, I'll just show you how to find one of the values just to save time. So if you want to find one of the values, you can go to second calculate and go down to intersect. Where does it intersect? Enter. And you could do your first curve down there, enter. Second curve, I think that's the second curve, yes, enter. And enter, and there's the intersection point, and I think this was the first value you got, was 0.745. 0.745, that's at one time. Okay, and this is solving for t for the time. If I want to find the other intersection point, I could just go to do the same thing. All right, so that would give you your three values. So just go to, so graph your, I did them over here. I turned this off. So basically this was the position function, and this was the line y equals 5, and where they intersect, that's when the position is, that's when x, in this case t would be 5. So, or I'm sorry, the position would be 5. I just set them equal. When is the position 5? And that'll give you the value, the time value, when the position is 5. Okay, so you're going to find out when x, for what values of x is the function 5. And that was one of them. You can find the other ones. So I hope that makes sense. And if you have any other questions, just ask me in class.